Database normalization is a process of arranging your tables, columns, and relationships between tables in order to avoid data redundancy and to attain data integrity. I would say to put correct data in correct tables in order to avoid CUD anomalies. Create, update, and delete anomalies. So let us discuss these things in detail. Why should we do database normalization, right? Let's take an example. Let's write a table which is in denormalized form. So this is my film agents table. It has data such as agent ID. We have agents such as RE Gold, Mari Silver, Tori Bronze, and Gori Diamond. They are from certain agencies. The agencies are located in Los Angeles, New York, Los Angeles, and Mumbai. There are some contact numbers, and they have customers. So this agent has two customers, Brad Pitt and Fakira. Mari Silver has only Johnny Water. Tori Bronze has Ned Stark, C. Nolan, and Solman Khan. And Gori Diamond has two, Rajani Sir and Saruk Khan. But this table is in denormalized form. Why do I say that? So it has certain issues. The same issues to avoid which we do normalization, right? So what are those issues? First of all, there is data redundancy. It's clearly visible. You can see that agency name has been repeated. See? Similarly, because the agency name is repeated, so is the office location and office contact. It's exactly the same, right? As I told you, we need to avoid CUD anomalies. CUD stands for create, update, and delete, right? So we need to avoid CUD anomalies. So what are these CUD anomalies? So let's start with create anomaly. That is also called as insert anomaly, right? By the way, agent ID is the primary key. So I will denote it by underlining the column name. So agent ID is my primary key in this film agents denormalized table. So let's suppose there's a new agency. There's a new agency in the market, right? Called as Free Folks. This agency is based in, let's say, Los Angeles, right? They have already acquired a client. So they have acquired one client called as Mortgage Freeman. The problem is, till now, because this agency is new, they don't have a particular agent. They're still finalizing the contracts and all. So they don't have an agent. So we cannot create an entry in this table right now for this new agency because they don't have an agent. That means this value will be null, which is still okay. But the primary key column will also be null. There's no agent ID because there's no agent. So we cannot insert this data into this table. So that's a problem. The agency is there, but we cannot insert data because we don't have an agent, right? So this is an example of insert anomaly. Let's look at an example of update anomaly. So let's say that New Cine agency has moved out from Los Angeles to San Diego, right? And they have to change their phone number, right? So let's say this has been changed to 222-44455, right? And this will be San Diego, right? This has to be updated, right? But the problem is that because this data is repeated in multiple rows, we are only looking at 4-5 entries right now because of my whiteboard size. But imagine this table has, let's say, hundreds of records. There will be at least few more entries, like 20-30 entries of similar data for new Cine agency. So we'll have to make sure that we update these new details, that is the contact, office contact number and office location in all of those rows, all those 20-30 rows. If it happens like that this information, this new information of office contact and office location gets updated in few rows and not in some other rows, not in the remaining rows, then the database or data will be in inconsistent state, right? So this is called as update anomaly. This is arising because you have data redundancy. Now let's look at an example of delete anomaly. So now we have an agent Gori Diamond from Firefolds Private in Mumbai, right? What if tomorrow Gori Diamond retires, or Gori Diamond, let's say, is no more with us due to some unforeseeable circumstances? So surely agent ID being the primary key will have to remove this entry of Gori Diamond from the table, right? But the problem is, if we remove that entry, the information about Firefolds Private Limited, right, will also be removed from the table. The agency information will also be gone. And if we assume that there's only one agent, Gori Diamond, for this particular agency, then we won't have the agency information at all. What about the clients, Mr. Rajni and Mr. Saruk Khan? So we cannot possibly delete this information just because the agent is no more. So this is an example of delete anomaly, right? There's one more issue with this denormalized table. Although we don't have something called as read anomaly, but let's suppose I want to find who is the agent or which is the agency working for Mortgage Freeman, Mr. Mortgage Freeman. So how do I write the query? Select agency from film agents table where customer 1 equal to Mortgage Freeman, or customer 2 equal to Mortgage Freeman, or customer 3 equal to Mortgage Freeman, right? So this is looks like a silly query. I mean, there are 3 columns for storing 3 customers. What if tomorrow we add 2 more columns to have 5 customers? So we'll have to add 2 more columns in each time in our queries. Feels a bit clumsy, right? Let's go one step ahead. What if we want to sort the data based on customer name, right? Alphabetical order. So on which column will we sort? On customer 1, 2, 3, what? So there are problems in retrieval of data also in this way of storing data in this denormalized form. So let's rather normalize this table. Let's normalize this database. In database normalization, there are few forms. You can achieve database normalization in stages. So the forms are first normal form, second normal form, and third normal form, right? Apart from that, also there are few more normal forms such as Boyd Cod normal form, fondly called as 3.5 normal form, and I guess there are 4th normal form, 5th normal form, and 6th normal form also. But it is generally said that if your database is in 3rd normal form, it is sufficiently normalized for any relational database management system based business application. So we will study normalization till 3rd normal form. What are the rules for attaining 1st normal form? 1st normal form says that each column should be atomic. That is, you should not have Fakira and Sakira, right? You cannot have values like that, 1, 2, no. Every column should be atomic. That means single value in every column. And to avoid scenario like this, there cannot be group of columns representing similar information. So we cannot have 3 customer columns. We can only have 1 customer column. The second rule of 1st normal form says that there should be a key which uniquely identifies each row in the database table. That key could be 1 column like agent ID or combination of 2 or more columns. So currently this table is not in 1st normal form. Why? Because it has group of columns which are representing similar information. In order to achieve 1st normal form, I will divide this table into 2 tables. So I'll separate out the customer information into another table. So now I'll call this table as agent info, right? And I'll create another table called as customer info, right? All right, so this is my customer info table. So we have Brad Pitt, Salman Khan, Fakira, Johnny Water, Saruk Khan, and Mortgage Freeman. So you can see here, I have customer ID is my primary key, right? So I'll underline that. C1 is my customer ID. Agent ID is A1. So I can identify that Mr. Brad Pitt is represented by agent A1, which is Ari Gold. Mr. Mortgage Freeman C6 is represented by A4, that is Gori Diamond, right? And it has customer city and customer pin code. So now our database is in first normal form because all the columns are atomic, so they have single values, and there are no more group of columns representing similar information. Also, as the rule says of first normal form, for each table there should be a column or a group of columns which should be uniquely able to identify each row. In short, there should be a primary key. So this, in customer info we have CID, and in agent info we have agent ID, which uniquely identifies each agent. So we have primary keys and we have atomic columns. So we are in now first normal form. Now, being in first normal form, we have resolved certain issues. We can add unlimited customers for each agent. Remember earlier we had 3 columns: customer 1, customer 2, customer 3. So at max, every agent could represent 3 customers. That limitation is now gone. In this table, you can keep on adding entries, right? So one agent can have as many customers he or she wants to represent. Sorting. Remember, we could not basically sort based on customer name. So now we could sort the data based on customer name because there's one column. Insert and delete anomalies on the customer table are gone. For example, I could delete a customer. Let's say Mr. Mortgage Freeman goes out of the planet. So in that case, I can delete this entry, right, of customer Mortgage Freeman, and still my agent information, if A4, Gori Diamond, will not be harmed in any manner, right? I'll retain that agent information. So delete anomaly is avoided. We still have certain anomalies left in this design. For example, we still haven't solved this problem, right? There's a new agency in Los Angeles, but they don't have agent, so they can't represent customers according to this new design. So although we are in first normal form, we still have certain anomalies left to be resolved, right? So we will now go to second normal form in order to get rid of those anomalies and have more data integrity and less data redundancy. In order to attain second normal form, you should adhere to all the rules of first normal form, right? As I told you earlier, they are progressive. Plus, non-key columns should be dependent on primary key. So first, what is non-key columns? So in this case, in this agent info table, agent ID is primary key. Here, customer ID is primary key. So all these columns are non-key columns, right? Now, primary key could be a single column, as it is in our case, or it could be a combination of multiple columns. So for example, here it could be customer ID and customer name. So at times, primary key is a composite key. It's a combination of 2 columns, right? So let's say here if CID and customer name form your composite key, then agent ID, customer city and customer pin code will be your non-key columns. Here, in our case, it's more simpler. Agent ID is the primary key, so all these are non-key columns. They should be dependent on primary key. So what do you mean by dependent? So in order to answer that question, are they dependent or not, you have to ask one simple question. Does that non-key column describe what this primary key identifies? So in this case, let's say office location column. It's a non-key column. Los Angeles. Does it describe what is uniquely identified by this primary key A1? This primary key A1 is uniquely identifying what? The agent, Ari Gold, right? Now, Los Angeles office location. Does it describe Ari Gold? Not really. It is actually describing his office, his workplace. So if your answer is yes, if it, for example, agent name, right? So does this non-key column here describes what is uniquely represented by primary key? A1 is representing this agent. Agent name is describing that agent? Yes. So it should be in this table. If the answer is no, in case of Los Angeles, this information should not be in this table. It should be in some other table. As simple as that. So that's what I mean by dependent. They say that for a table to be in second normal form, it should have a single purpose. It should have a single responsibility. So our current database design is not in second normal form. Why? In agent info table, we have 3 columns: agency name, office location, and office contact, which are not describing the agent, which is uniquely identified by the primary key. They are describing his or her workplace. So this is not in second normal form. So let's make our database in second normal form. How do you do that? As I said, if your non-key columns are not dependent on your primary key, right? Meaning, if the non-key columns do not help describe what is being uniquely identified by your primary key, move those columns into other tables. Take them away from here. So let's do that. So I have divided my database into 3 tables now. So agent info has agent ID, agent name, and agency ID. So agent ID is my primary key and agency ID is my foreign key. Agency info table has agency ID, agency name, agency location, that is agency office location and office phone number. And customer info has customer ID, C1, customer name, Brad Pitt, customer city, Los Angeles, and customer pin code. Right? Now, we have established a relationship between agents and agencies. There's a foreign key of agency ID. Thus, we know that this agent, Ari Gold, belongs to New Cine Agency. What about, we have removed the agent ID foreign key from the customer info table. So how would we know Brad Pitt is represented by which agent and then accordingly which agency? So we'll create a join table. So this is my join table. This is called as join table or intersection table. It will have just 2 columns, agent ID and customer ID, both foreign keys. Join tables are usually used to represent many-to-many relationship. Here we can have an agent can have many customers and a customer can be represented by many agents. So from this table, we get the information that agent A1, that is Ari Gold, is representing customer C1, that is Brad Pitt, right? So this is our join table. All the non-key columns should be dependent on primary key. So let's check here. Here, agency ID is a foreign key, right? So it's not a non-key column. Rest columns are dependent on agent ID because they describe the agent. Here, agency name, office location, and office phone are describing agency. So they are dependent on primary key. Here, customer city, pin code, and customer name are describing customer, which is uniquely identified by this customer ID for primary key. Hence, they are also dependent on primary key. So all these 3 tables are second normal form compliant. So is this table because there are only keys here. This is foreign key, this is foreign key. So these rules do not apply here at all. So all these tables are in second normal form. So we are in second normal form. Now this in itself is a very good database design. We are almost there. In fact, 3 out of our 4 tables are already third normal form compliant, except for this customer info table. So let's see now what is third normal form. So third normal form will be all the rules of second normal form, right? Plus all the non-key columns should be non-transitively dependent on primary key. So in second normal form, we had rules such as all the non-key columns should be dependent on primary key. So we have just added this keyword non-transitively. So what is non-transitive? So let's see what is transitive. A depends on B, and then we say B depends on C. So in turn we say A is dependent on C. So this is transitive property because third normal form says all the non-key columns should be non-transitively, that means directly, non-transitively dependent on primary key. In our case, this customer info table is violating that rule. How? So we have the primary key as customer ID. Customer name describes the customer, which is uniquely identified by this primary key. Hence, customer name depends on primary key. Customer city, the same. It describes the customer. It directly depends on the primary key. Now, customer PIN code. Customer PIN code depends on customer city, and customer city depends on customer ID. So here, customer PIN code is transitively dependent on the primary key customer ID. Not directly, but transitively through customer city column. Hence, this table is not in third normal form. So let's make it in third normal form. So what I'm going to do is, I'm just going to remove this customer city column from this table. And I'm going to add another table. It will be called as customer PIN codes. It has customer PIN code and customer city column, right? Now this is the foreign key here, joining these two tables. Hence that non-transitive rule does not apply on this column anymore. It's not a non-key column anymore. It's a foreign key column. So this table is in third normal form. And here also, city is describing this PIN code. So this is also third normal form compliant. So now our database is in third normal form. It's a good relational database management design when your database is in third normal form.